Hey everyone, welcome back. This is lesson 9.2, Piecewise Functions. Your objectives for this lesson, you're going to be able to write and graph piecewise functions. You're also going to be able to use piecewise functions to describe real-world situations. The vocabulary for today is piecewise function and step function. A piecewise function is a function that is a combination of one or more functions. The rule for a piecewise function is different for different parts or pieces of the domain. For instance, movie ticket prices are often different for different age groups. So the function for movie ticket prices would assign a different value or ticket price for each domain interval or age group. Remember, when using interval notation, square brackets indicate an included endpoint and parentheses indicate an excluded endpoint. And we'll see that again in just a minute. I'll review it with you. All right, here's our first example. It says to create a table and a verbal description to represent the graph. So the first thing we want to do is create a table, and we'll just look at our chart that they've given us, and we can see that this is about mixed nuts, and it's going to show us the price per pound of mixed nuts. So notice that the more I buy, the less I pay. So let's talk about the domain. Now remember, our domain is our x's, all right? So we're looking at the x's here, all right? So and the domain of the function is divided into three intervals, okay? So here's an interval, and then our last interval goes on out. So if we put it in the form of a table, we can see our first interval is from 0 to 1.99. Notice I don't go all the way to 2 because it's an open circle there. So the way we would write that interval for that domain is going to be from 0 to 2. And notice 0 is the cost is included, but 2 is not included. It's the open circle. So it goes all the way up to 2, but doesn't actually touch 2. Okay, so now our second interval is going to be from 2 to 4.99. So this is for when it weighs 2 pounds to under 5 pounds. And let's look at what that would be written like. Notice I have it totally filled in here, but open here. All right, so it's going to be this square bracket, and then the 5 shows that it's not including 5, so it's just going up to $4.99. All right, and our final domain is going to be when it weighs over 5 pounds. Now, 5 pounds is included in there, so when we write it, we're going to have the square part of our bracket 5. And remember, anytime we go to infinity, we use this rounded bracket because there's really no ending point for infinity. So we'll just use the rounded bracket. All right, step 2 is we're going to write a verbal description, and this is pretty easy. We're just going to take our chart here, and we can say that mixed nuts cost $8 per pound for less than 2 pounds, $6 per pound for 2 pounds or more and less than 5 pounds, and finally $5 per pound for 5 or more pounds. Okay, try this one on your own to see if you're understanding this better. It says create a table and a verbal description to represent the graph. So go ahead and turn your video off and give it a try. Okay, so when we take a look at this graph, we can see that if you want to get golf green fees, know what your price is going to be. If you're wanting to golf between 8 and noon, your fee is going to be about $28. If you want to go golfing between noon and 4 p.m., your fees are going to be $24. And if you want to go golfing anytime after 4 p.m., obviously they don't have a lot of people that want to go golf late in the afternoon. Their fee is only $12. So they get a little price break if you go later on in the afternoon. So let's take a look at what you should have done. So the first thing to do is create a table. And because the endpoints of each segment of the graph identify the intervals of the domain, use the endpoints and points close to them as the domain values of the graph. Remember, our x are going to be our domain, and the domain of the function is divided into 3 intervals. All right, so let's see how they go. Notice that $28 for 8 to noon. So our domain on here is going to be written like this, from 8 to noon. So 8 to 12. Notice 8 o'clock is included, 12 o'clock is not. If you come right at 12, you're going to pay the next lower rate. All right, and if you come from 12 to 4, here's what your domain would look like. 12, notice it's included the square bracket, and 4 is not included. All right, and that would be right here. But if you come at 4 o'clock, you're going to pay $12, and your domain is going to be the square bracket from 4 all the way to 9. Okay. Continuing with this, let's talk about our verbal description. Again, here's our table and our graph. The green fee is $28 from 8 a.m. up to noon, $24 from noon up to 4 p.m., and $12 from 4 up to 9 p.m. A piecewise function that is constant for each interval of its domain, such as the ticket price function, is called a step function. You can describe piecewise functions with a function rule. The rule for the movie ticket prices from example 1 on page 662 is shown. All right, so let's take a look at this, and we're talking about movie ticket prices, so let's see if we can figure out what this says here. It looks like if you are between 0 years old and 13 years old and you want to go see a movie, you're going to pay $5. If you're between 13 years old and 55 years old, you're going to pay $9. And if you're older than 55, you're only going to have to pay $6.50. So you can see we have the children's price, the adult price, and the senior price. All right, a function like this is read like this. F of x is 5 if x is greater than 0 and less than 13. F of x is 9 if x is greater than or equal to 13 and less than 55. And finally, f of x is 6.5 if x is greater than or equal to 55. To evaluate any piecewise function for a specific input, find the interval of the domain that contains that input and then use the rule for that interval. You'll see that this is quite simple. For example, evaluate each piecewise function for x equals -1 and x equals 4. So the first one we're going to do is x equals -1. So the first thing we want to do is think about where -1 is. Is -1 less than or equal to 2? Well, yes, it is less than. So the function we're going to use is 2x plus 1. So all we have to do is fill in our -1 then for x. So 2 times -1 plus 1 equals -1. So our first answer is -1. We would say h of -1 equals -1. The second time we look at x equals 4. 4 is greater than 2, so we're going to use this equation and fill in. 4 squared is 16 minus 4 is 12. And so there it is. So h of 4 equals 12. So you just choose which one to use and then solve. Okay, again, the same instructions. We're going to evaluate for -1 and x equals 4. So first, let's look at -1. So I can see that -1 is less than or equal to -1. So I'm going to use this. And so all I have to do is say g of -1 equals 2 to the -1 power. Remember, -1 power doesn't mean negative there. It means to write it as the reciprocal. All right, the second one, when we check for 4, 4 is greater than 1. So I'm going to use this one now. So 5 times 4 is 20. Pretty simple. All right, try this one on your own. Turn your video off and give it a try. All right, so on this one, let's evaluate each piecewise function for, at first, x equals -1. All right, is -1 less than -3? No, it's not, so we're not using that one. Is -1, let's see, greater than -3 and less than 6? Yes, it is. So we're going to use this one. So all we have to do now is so simple, is just say, okay, f of -1 equals 15. That's all you have to do, okay? And then the next one says check for x equals 3. So let's go through it. Is 3 less than -3? No. Is 3 greater than -3 and less than 6? Yes. Is 3 greater than 6? No. So again, all I have to do is the same thing. F of 3 is also 15. So I hope you got 15 for both of those. That was kind of a trick question. Try this one on your own. Turn your video off again and try it again. Okay, it said evaluate each piecewise function for x equals -1. So let's check. Is -1 less than 0? Yes, it is. So we're going to fill in this one. All right, and so we're just going to, everywhere there's an x, I'm going to put in -1. So -1 squared is 1 times 3 is 3 plus 1 is 4. All right, let's check when x is equal to 3. Well, 3 is greater than 0, so this time I'm going to use this one. So everywhere I see an x, I'm going to put in 3. So 5 times 3 is 15, minus 2 is 13. All right, you can also graph a piecewise function by graphing each piece of the function. Okay, let's graph this function. So let's take a look at it. We can see that these are both linear because the exponent on our axis is 1, so I know it's a linear. The function is composed of 2 linear pieces that will be represented by 2 rays. Because the domain is divided by x equals 0, evaluate both branches of the function at x equals 0. All right, so here's what I would do to graph these. I know the rules for graphing, so I can say when x is 0, that makes this whole piece 0, so y is 3. So I'm going to go up 1, 2, 3, and put a point here, okay? And it says rise 1, run 4. So I don't have enough room on the top, so I'm going to rise 1, run 4. I'm going to just go backwards a little bit. Rise 1, run 4. 1, 2, 3, 4. Okay, so here's my line right here. All right, but notice that it says if x is less than or equal to 0. So I'm going to have to go ahead and I'm going to have to not go all the way there. I'm going to have to go less than or equal to 0. So I'm going to have an open hole here, and I'm just going to draw right there. Okay, so there's my open hole, there's my line. All right, now my second one, I'm going to do the same thing. Go ahead and graph. It says when x is greater than or equal to 0. So I know I'm going to fill in my hole here. When x is 0, y is positive 3 again. This time I'm going to go down 2 over 1, down 2 over 1, down 2 over 1, down 2 over 1. Okay, so here's my new line. I could also go up 2 over 1, but my problem says only go when x is greater than 0. So my new point is going to be right here, also at 3, but going down. So I'm not going to include this area up above here because that's only if x is greater than or equal to 0. Okay, here's another example. It's a little more complicated, but it's not going to be too bad. So we're going to have, notice I have, it looks like I'm going to have a parabola here because my highest exponent is 2. So I'm just going to do a little sketch on what I think it should look like at this point, and then we'll turn the page and take a look at what it really looks like. So I know my regular parabola looks like, and this says to move it 3 places down. So I'm going to go 3 places down, 1, 2, 3, and I'm going to make my parabola, but this is only when x is less than 0, so I'm just going to have that going up like that. My next one, I can see that this is going to be a line because my highest exponent is 1. So it says when x is 0, y would be -3. So I'm going to start there, and I'm going to go up 1 over 2. Up 1 over 2, up 1 over 2. So, and this is only when x is greater than or equal to 0 and less than 4. So it's going to be something kind of like that. And then here I have another parabola. Notice all of those learning how to translate things. This one says I'm going to go x my parabola is going to go 4 places over on the x and then 1 place down. So 1, 2, 3, 4, and I'm going to go 1 place down. And so now my parabola is going to look something like that. So this is what I am thinking that my graph is going to look like. Let's go ahead and take a look at another way of doing it. Okay. All right, so let's graph this using a table. So when I put together a table, I am going to take a look at my first piece, and that's when x is less than 0. So I choose -2, -1, and 0, and fill in each of those, and I get 1, -2, and 3. And then when my x is greater than or equal to 0 or less than 4, I'm going to use these numbers here. And then finally, when x is greater than or equal to 4, then I'm going to use my final equation here. And to graph it, we see pretty much what we looked at just a minute ago when we just kind of sketched it out. So no circle is required at 0, 3, -3, and at 4, -1 because the function is connected at those points. So even though this is x is less than 0, we would think it would be like this, but because the next one 0 is equal to, that means we get to include it like that. And then here x is equal to, greater than or equal to 4, so again we're going to go ahead and just fill that all the way in. So there's no circles on this one, open circles. All right, so turn your video off and try graphing this one on your own and see how you do. It says f of x equals 4 if x is less than or equal to -1, and f of x equals -2 if x is greater than -1. So turn your video off and try it. All right, so that's pretty simple. We're just going to say, remember, y is f of x is the same as y, so we could say y is equal to 4 if x is less than or equal to -1. So let's figure out when x is -1, and let's go ahead and plot that. Here's x is -1. It says y is equal to 4. So all we have to do is just go ahead and show that all of those x's that are less than -1, it will be at 4. And when x is greater than -1, and notice there's not an equal to sign, so we're going to have an open circle there. And when it's greater than, y is -2. And it's just going to look like that. All right, here's one for you to try on your own. Turn the video off and give it a try. All right, when we look at the x's, we can see that the function is composed of 2 linear pieces, and the domain is divided at x equals 2. So let's take a look at how to graph that. All right, so when you graph, you can easily just make a table of points and choose some points when x is less than 2. So here's a bunch of points where x is less than 2. And then choose some points where x is greater than 2. So there's some points there. And then all we have to do is go ahead and plot them and add an open circle at 2, -6, because notice it's not including 2. All right, so here's our point, and there's our ray. And then we're going to have a closed circle at 2, 5, because it's equal to. So I'm going to have a closed circle here. And just go ahead and plot those points and make a ray, and that's what your graph looks like. Notice that piecewise functions are not necessarily continuous, meaning that the graph of the function may have breaks or gaps. To write the rule for a piecewise function, determine where the domain is divided and write a separate rule for each piece. Combine the pieces by using the correct notation. Remember, for this next section, remember the distance formula, distance equals rate times time, can be rearranged to find rates. R equals distance over time. The rate equals distance over time. Okay, let's look at this example. It says Shelley earns $8 an hour. She earns $12 an hour for each hour over 40 hours that she works. Sketch a graph of Shelley's earnings versus the number of hours that she works up to 60 hours. Then write a piecewise function for the graph. All right, so first step is we want to make a table to organize the data. And so what the problem says is that if she works 0 to 40 hours, she makes $8 an hour. Anything over $40, she gets $12 an hour. So step 2, we're going to take our same table that we already made, and because the number of hours worked is the independent variable, we're going to determine the intervals for the function. So she works equal to or less than 40 hours. Her interval is going to be the hours is greater than or equal to 0 and less than or equal to 40, written like that. And then if she works more than 40 hours, her interval is just h is greater than 40. So let's keep that information in line and move on to step 3. All right, so step 3 says to graph the function. So she earns $8 per hour for 0 to 40 hours, and then after 40 hours, she earns $12 per hour. So we can draw our graph in, and it looks like this. And step 4, finally, we have to write a linear function for each leg. So we're going to use the point slope formula, and we'll use m, the slope is 8, because she's for the first 0 to 40 hours. Every hour she gets $8, so that's our slope. And then after that, she's going to have 12 hours, so that's going to be our slope for the second piece. So we can write an equation, and as you can see, if it's 8 hours, it's 0 to 40. H is somewhere greater than 0 and less than 40. And 12 hours is going to be using our point slope formula. You can choose 2 points. 40 hours makes $320. So just fill that into your point slope formula and get an equation, which is right here. And so if you work more than 8 hours, if you make more than 40 hours, then this is the formula that you would use. All right, and that is the end of our lesson for today. Hope you learned a lot about piecewise functions, and we'll work on this some more in class tomorrow. Have a great day. Bye.